Yeah, thanks for having me. I was checking the community a bit before I came because it's my first time, and I checked yeah, how many men and women will attend, and apparently there is like 85 guys attending and 3 girls, and I actually can recognize the 3 girls here. So I was thinking, hey, it resembles me my previous job, like a Christmas parties of my previous job. The only difference is that the girls never turned up. But apart from that, it's very similar. Yeah, so my name is Rado. I'm a data scientist, and I would like to show you how we go about development, deployment, and delivery of data products in Credo. And we use fully open source technology stack. But before talking about data products themselves, let me step back and say explain what I mean by data products. And like the previous step, there is a previous step before the data products, and this we generally call data insight, and it's just an umbrella term for anything that any type of script. It can be an R script, it can be a Python predictive model, it can be an SQL script or some kind of visualization. But the important thing is that it's type of a script that you have to supervise. So you have to really sit behind the computer, and then when you want to run it, you have to push the button and execute it, and hope that it will run. Sometimes it does, sometimes it doesn't. And you work with kind of a data that you can scrape around, and on an infrastructure that you have at hand. So it's typically your laptop. And what I mean by data product is kind of the next generation. It's when you take the data inside and robustify it a bit, so it can run automatically. So it has this kind of production grade flavor in it. And you can then take this data product and you can schedule it, and it will run without your supervision. And you can schedule it for some specific time in the future, or you can expose an API that can receive requests. It is also running in a data infrastructure that is there, and it's kind of stable. And the idea is that it's really robust, so it will run even when you leave the company or when you are not at work at the time. So that's the data product. And my talk, or what I want to talk about, is how you get from here to there in a kind of simple way, hassle-free way. Yeah, simple it's an important word because this is nothing new. You all know that this is important, and a lot of companies try to do this, but a lot of them also fail. And I was thinking of the reasons why this might be, and I think, yeah, the reason is that turning data insights into data product is the procedure is composed from like 3 steps, and in this, which is development, deployment, and delivery, and these 3 steps have like different key persons, key stakeholders in the process. And these different stakeholders, they kind of have different KPIs. So they're trying, all of these people are trying to get to a data product in the end of the day, but they are following a different track slightly. But not only that, also the skill set of these people is kind of different. So data scientists are typically mathematicians or machine learning. People with machine learning background, and which are good with Python and R and SQL, while data engineers are more like IT people, software developers, etc. So even communication between these key stakeholders, it's kind of hard. Data science project managers are really people who are focused more on delivering and on the project management. And also the challenges that you face in these 3 different stages are kind of different. So data scientists are typically short of data or computational resources, or some packages. That's typically what is missing. You're always missing some package. While data engineers, they're trying to wrap their head around how to actually mix all the different requests for different packages and data, how to make a data infrastructure such that the data scientist can work in it, and how to manage all the dependencies. While the project managers are more about delivering results on time and delivering results that you can actually turn into money, into business value. And so why it is complicated? It is complicated because you have these three phases, but you need to have some. Ideally, you want to have one tool or one environment where you can accommodate all the needs of all these people. Yeah, but still, it's kind of hard to do, but in the end of the day, it matters because, and there are quite some companies that I still can see that are in a first phase where they have a lot of they focus very hard on having very good algorithms, bright data scientists, and so then they end up with a lot of different scripts that they somehow glue together, and then they run them and hope for the best. And sometimes, I mean, it can. Don't get me wrong. It can work. It usually works. It's like for a week, it would be fine. If you're lucky, it can work for a month. If you really have a good run, it can last for a year, but eventually it will crash. And I've seen this. And it typically crashes when you need it the most. So when you really need to deliver something, then some guy is on a vacation and the script that he wrote and no one else knows will crash, and then the entire workflow doesn't work. So that's something I've seen. So then the next step is that so you hire smart data engineers and DevOps, and these would turn the workflows turn this kind of mess into something neat in a workflow, and that's fine. So you can sleep better, but typically getting from here to here, it's quite expensive and it takes quite a lot of time. And still, if you're here, you're not making any money because you only start making money when you run the data through your data products. So that's kind of a motivation. That's how I wanted to motivate why we actually need to have this very stable, very robust data product. And so that's in my opinion, or that's the goal of my talk. And there are plenty of solutions. Everyone is coming up with something, and here I would like to show how we think about it and how we do it. So we are a small company, so we are not writing everything from the scratch. We are assembling together a lot of open source technologies, and normally we start with a cloud instance. So we do this on the cloud. Although I'm quite sure that something similar something similar that I'm going to show, you can also deploy on. You can also deploy on premise, but we haven't tried, so I wouldn't be sure, but it should work. Okay, so coming back, so you have a cloud instance, so we typically rent the cloud. We work with Azure or AWS, and on the cloud we deploy Kubernetes. How many of you knows Kubernetes here? Everyone almost. Perfect. So I don't have to explain. For those who don't, high level, it's kind of a framework where you can manage containers, and I will talk in a bit what the containers are. But yeah, so you can basically fire up, scale, and manage your containerized applications. And the idea is that, as I said, you have a lot of dependency hustle, and you have your data insights, so your either machine learning scripts or SQL codes or whatever. And you put these into the containers, and the containers, they kind of create the living habitat for your script. So all the dependencies are inside, and your code are guaranteed to run whatever happens outside of the container. So that's kind of the big idea of the containers. And Kubernetes is a technology that is able to start and shut down these containers and link them together and connect them, etc. On the top of Kubernetes, we deploy Kubeflow, which is a machine learning framework that is developed for Kubernetes. How many of you know Kubeflow? Okay, I thought so. So not so many. It's a relatively new project. It's still, I think, in a beta version. It's been developed by Google, and they're about to release the first stable version somewhere in Q2 of next year, I believe. What we do in Kubeflow, we use Kubeflow as the core, as the integrated development and deployment environment, and that's the place where we develop these machine learning pipelines. So these organized, neatly organized workflows of the containers. And next to the Kubeflow, we deploy Elastic Stack. How many of you know Elastic Stack? Okay, cool. So Elastic Stack, it's a lot of things. It's quite a big project that encompasses smaller tools. So you can use it for different things. We mainly use it for dashboarding. So there is a kind of a dashboarding tool inside of the Elastic Stack, which is called Kibana. And we use Kibana to create dashboards on the runs of our pipelines. And yeah, and as I said, so on the top of Kubeflow, or to the Kubeflow, we deploy the custom Docker containers. And why custom? Well, the reason being that Kubeflow offers their own containers, but Kubeflow, as it is developed by Google and people around TensorFlow, it's kind of used for different workflows. It's mainly used for TensorFlow and unstructured data, etc. So also the Docker images that are there are kind of tilted or biased this way, and the workflow that we typically do in Credo are more for structured data and the old kind of type of predictive modeling, if you will. And so yeah, so we have our own node containers that serves our purpose better. All right, so that was the boring theory or the background, and yeah, a bit of a motivation. And now fingers crossed that the internet will work, because I'm going to try to do something that Boy will always tell me not to do, which is to do a live demonstration. So yeah, let's give it a shot. But before the demonstration, still one slide. So what I'm going to actually show you is this workflow of a couple of containerized scripts. So a couple of these data products chained into a workflow, and that workflow we and also Kubeflow calls it a pipeline. And the pipeline that I'm going to show now will go like this. So we first are going to extract the data from the storage account. So this is running on the Azure cloud, so from the Azure file system, I think it's called, or storage system. So we will extract some CSVs into a relational database. I have MySQL running there. In that relational database, we wrangle the data into kind of a modeling data mart, so really something that typically data scientists or the machine learning engineers would start from. So very, very wide table with a lot of features and a target. And we would store this into one table. We would run some rudimentary checks on this table, like really data quality checks, and then use this as an input for two predictive models. Now, why the colors and why I'm showing this? The reason being that it's kind of a hybrid pipeline, in a sense that the runtime environments that I'm using are different in the steps. So I have like 3 SQL steps, really submitting remotely SQL script to a database. And then I have 2 Python codes, one for the data check and one running the XGBoost model. running the scoring routine of an XGBoost model. And then I have a Spark, another Spark code that is submitted to a Spark cluster. Okay, and now really the demo. So this is the main page of a kubeflow, and I'm going to focus on two things. So in this panel, you have different things you can do, and they are always adding new stuff. Some are still experimental, but the two things I'm going to show are the notebook servers. So that's what we use as an integrated development environment, and the pipelines. And a pipeline is basically a vehicle for deployment. So I started with the notebooks. I create my namespace, and I see the notebook available. Currently there is one. So this is the custom image, the custom Docker image I was talking about. Now I connect to it. And it basically spins up Jupyter Lab. And Jupyter Lab with different kernels that you typically, or that your data science team typically want to use. So you have a Python kernel, and the Python kernel has the standard Python, and then also a PySpark. And then there is R kernel, and then we also added an SQL extension where you can write queries. And here on the left panel there is the folder structure. And for instance, in the development, I have some codes. This is really actual demo that I was doing. So these codes are really something meaningful. So I will open, for instance, this one. So yeah, so it's really standard SQL code, and then you have just right next to it you have Python code. Deployment scripts. And so, for instance, this is my scoring script for Python. So this would be still what I would call data insight. So this is just a script, and then you kind of package the script, or you inject the script in a container, and then you compose a pipeline with these containers. That would be the deployment. So the point here is that this is really a standard Jupyter Lab where you can do a lot of stuff, and you do it remotely on the Kubernetes. So you can define different type of resources. If you need a stronger machine, you can define a stronger pod. It's quite cool. And the point is that when you're done, when the data scientists are done with this, then they can just take the code which is there and deploy it very easily. So you have everything stored in the same place. So you just take your code and you wrap it and you construct the pipeline. I'm not going to show how you construct the pipeline because it's just a Python code, and it's not hard. It's few lines of the code. But I'm going to show how it looks when you do that. So you go to the pipelines, and here you can see how your pipelines look. And basically, this is the same pipeline that I was showing before. Before it stopped working. So you load the data, you transform them, you prepare, and then you run two codes and a data check. And this for me is a deployment. This is there, it's ready, it's versioned, it's stored, all the metadata underneath are stored somewhere. So this is ready, waiting for you to execute actually. Important thing, every of these steps is represented by one container, which has your script injected into it. And then you can just run. So you create a run. I will give it some name. For for instance 2019-01. I'll choose an experiment. Experiment is just a name for a workspace. So you stash different runs under the same experiment. I don't know why they call it this way, but that's the way it is. So I'll go under demo, and I would say it's one of run. And yeah, importantly for each run, you can define parameters. And these parameters are actually, this is not something that would be hard-coded. This is really something that Kubeflow interprets from how you set up your containers. So if your containers are asking for certain type of parameters, they will all be listed here, and you can parameterize it. So then you just run it. And this is very rudimentary way of delivery for me. So you just run it. It means that it will take it will connect to the data, load the data. Now he will show how he progresses over the run. Normally it shouldn't take that long. So yeah. Okay, so now we have a run running, and I was also saying something about monitoring and dashboarding, and that we have in Kibana. So we have a dedicated Kibana dashboard, where here I'm just plotting some kind of random. Well, it's not random, but it's just a demo dashboard. What I'm trying to say is that you can organize this whatever you want, and this is actually about how the scores from the model. So from these two models that are now running, how they are flying into the database. So here you have really real time. This is like how your database is getting filled in. Here you have some event rates. Distributions, how many models you have in your repository, that it's a batch model, and how many scores. You can see that I have one model because the other model is still running. The PySpark model is still running, so it hasn't arrived yet here. But he will update as soon as this is done. He will update. Yeah, and then I created just another dashboard, just to show you can do whatever stuff you want. So here is a dashboard for the data checks, for instance. Again, yeah, just the rudimentary stuff, number of rows, columns, what are the columns with the most NA values. This one will become more apparent when I have more runs. So let me start another run. So imagine that this is a banking example. So imagine that you have a next month when you want to run the same pipeline. The only thing you need to do, you can either do it manually like I'm showing, or you can really schedule it. But now, for the sake of demo, I'm running it manually. So I would say run for February, for instance. I would put it to the same experiment. And here I would just change the parameter. This parameter tells all the codes that are running underneath what data to select for the wrangling, what data to send to the scoring to the scoring, etc. Yeah, and then I just run it. Go back here. Yeah, so in the meanwhile, also the PySpark model finished. So yeah, so the thing just updated. That's it, and now it will basically update for the next run. Do I still have a minute or two? Yeah. Okay. So because this was all batch, and I also wanted to show you, like, okay, imagine now that one of the models, say the Python model, is okay. That for instance, the business likes it, and they would like to deploy it in real time. So they would like to have an API that would be listening for the incoming traffic and scoring on request. that you can do as well. You supposedly are able to do it in Kubeflow as well, but I haven't tried it yet. So what I've done so far is that I deployed the API written in Flask directly to the Kubernetes. So you're not going to be able to see it in the pipeline yet, but what I want to show is that I also created a mocking script that is sending the traffic to the API that is exposed like every 3 seconds. And I'm going to run the mocker, and you will see that, yeah, the thing will update for that. Yeah. So now I started the mocker, and you see that there are no models in real time running yet. And now he's already sending the traffic, and this is updating every 5 seconds. So we should have an update in a bit. Yeah. So now we are running 1 models in real time. And the model that we are running is the XGBoost. So you will see, yeah. So you will see that here the scores will come every few seconds. They will go up by 1 or 2. So yeah, so this is it. So you have basically, you can create everything under one hood, and this is, yeah. So this is basically it from the demo. I still have maybe 1 slide. Yeah, this is basically it. It's the main message is that it's all open source. It didn't cost almost anything except for the cloud rental, which is not that expensive. All right. So. Yeah. Yeah, this is a commercial slide, but I don't have much time for it, so it's just about us. I had to put it in.
You have to start with it.
Yeah, and now, yeah, and now that's it. So thanks a lot. Do we have time for Q&A?
Yeah, 2 or 3 questions.
2 or 3, okay.
I can also do it. So I'd like to ask, how much effort does it take to set this on AWS?
What do you mean by this?
The Kubernetes and Kubeflow and everything you showed.
In terms of man hours? I don't know, because I haven't set up, for instance, the Kubernetes I haven't set up. Our solution architects and IT people do that. I'm a data scientist, so I do more the part starting from Kubeflow, containers, modeling, and these kind of things. So I don't know. But modeling and setting up pipelines, once you know it, it's like this. It's really fast.
Thanks.
Yeah, I have a question. If you go back to the slide when you showed like there's data scientist, data machine learning engineer, and the machine learning PM, right?
Yeah.
Like, what would you think like the pay scale of these 3 guys should be compared?
Pay scale?
Yeah.
I don't think I'm the good person to tell anything about this. I really don't know. I would like to know, but I don't. I simply don't know. I hope they are paid equally.
Okay. Okay.
No, sorry, I really don't hold that pay scale.
I think you hope the better ones are paid more.
Yeah.
Not equal.
Depends on the data, not the data process.
So can I have 1 more question?
No.
So where do you define the problem to work on? Like how do you do, like you said you're a data scientist, so do you define yourself what to work on, or how is the process?
Nah, this one was, this is really a demo that we were showing to one of our clients. So this I defined because I kind of know what they are after. But yeah, I think it's typically driven by the data science team, I guess. So I think these guys, these kind of data science PMs, they run around, or feel free to disagree. There are many different views on this organization, and I don't really want to go into that, but this is one of them. And in this view, the data science project managers are people who have this business acumen, and they are running around the organization and seeing what are the pain points. And then they try to turn the business problem into some kind of mathematical problem, and then such that the data scientist can digest it and turn it into a code. And then it goes this direction. So it starts here, then it goes here, here, and then it ends here as well.
Okay.
One more question, please. I would like to have a question about the platform.
Yeah.
How does it help you actually with the code? Does it help you refactor it? For example, if you use something in older Python, and we all know that Python 2.7 is going to be obsolete. So does it help you to make changes in the older code, or do you have to do it on your own in other editors and stuff? Does it actually care about it?
Well, I don't know if I'm gonna answer the question, but I'll try. I think you don't care, because that's the nice thing about containers, that once you put your code in a container, say in Python 2.7, you're sure that it will, and since it's a containerized application, all the dependencies and the runtime is frozen, it's inside that container, and you're sure it will run forever, so you don't have to touch it. But of course, if for some reason you want to come back in 5 years and change something, you have to change in that runtime environment. So yeah, and I'm not aware that it would help you somehow, like with code syntax, or if this is what you were asking.
Okay. Thank you very much.
As you're using the open source stack, what about the security and vulnerabilities? How do you approach that?
I'm sorry, what about what?
Security and vulnerabilities, possible ones. Do you have any solutions, like how to test and check with third-party tools for that?
You mean like penetration tests, or
Anything like?
well, okay, I'm not really a security expert, but as far as I know, all of this is taken care by Kubernetes, and Kubernetes is quite stable thing. So if you set up security on the level of Kubernetes well enough, then everything else it's taken care of by Kubernetes, because then everything else is just containers being deployed on Kubernetes, and if the Kubernetes security is fine, then you're good. And regarding Kubernetes security, I don't know if there are a lot of people questioning this. I mean, Google runs hundreds and thousands of microservices on Kubernetes. Probably they figured. I don't know.
Okay, so I would like to thank Radovan for his presentation.